Okay, well, what we're going to do is we're going to talk about how to create a confidence interval, how to construct one confidence interval, and what are the steps to do this on like an AP test or whatnot. So the first thing that you have to know how to do is how to do this four-step plan of state, plan, do, and conclude. That is what you're going to be using for all of the different tests, interval process, and whatnot. Okay. We're going to then talk about how we construct this confidence interval and also the plan that is needed in order to, or the constraints of the plan that are needed in order to accomplish the do and conclude part. All right, so without further to do, let's get started. So what we have right here is a four-step process. And so you want to write this down, all right, in your notes, because this is what you have on all AP exams. So the four-step process really boils down to this: state, plan, do, and conclude. That is used for all constructing of all different intervals, whether a z-test, t-test, for means or for proportions, or for the difference of proportions or difference of means. It's always the same. It's state, plan, do, and then conclude. All right, now, when you're talking about a confidence interval, we have two different types of confidence intervals. We have confidence intervals. We have one sample. All right, we have a one sample. We have a two sample. All right, we can have a Z. All right, we can have a T. All right, and we also can have for proportions, all right, for P or for the mean, okay, or for the mean. All right, so there's basically two different ones. So we have a one sample, two sample. You got to figure that out. Is it a Z or a T? Which you may or may not know what T is, but Z or a T. And then for P or for P, the proportion, or for the mean, what we have there. So we're going to start out mainly talking about for P, okay, for P. And also, we're going to talk about for Z, and then also for this first one, we're just going to boil down to a one sample. Okay, so what you need for the states, you need to state your parameter, okay? What is your parameter and the level of confidence that you want to proceed with. The next thing is you want to name the procedure conditions, all right? Name a procedure and then the conditions. And then you want to do general, specific, formal, plug-in, and final interval. And then conclude, we want to interpret what our confidence interval is in context. So we are 95% confident that the true proportion in this case is going to be a proportion of blah, 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 is going to be found in this interval. Okay, so the first thing is we got to choose choosing a sample size, all right, for n. And so we need to sometimes solve for n when we're doing this. And when we solve for n, we always need to round up when we're doing that. If we have a p-value or the p-value is unknown, we can say that our statistic is 0.5, and that's a conservative estimate what we have for our sample statistic. So in order to get our margin of error, that's found margin of error, we're going to need this. Okay, and we're going to go through what those are in just a little bit. This is right here our critical value. All right, our critical value, which is known for Z. And then also we have what is our standard error. All right, standard error, which is really SKA or AKA our standard deviation, All right, so let's go through and find out how we find these different things. So first off, when we state our conditions, okay, all right, our parameter and our confidence level, all right, we state our parameter. So either are we looking for proportions, all right, are we looking for P, the true proportion of whatever this is, all right, so looking for a P, in this case we are going for a P, all right, the true proportion, all right, of whatever context we have and to whatever confidence level we have. So it could be a 90, usually 90, 95, or 99. Name a procedure. Well, we're going to be looking at a one sample, all right, Z interval. That's a Z, all right, one sample Z interval. For P, all right, one sample Z interval for P. We're going to talk about different name procedures. And now how do we find these conditions? So, and the do and conclude, so we're going to go through that right now. So the conditions in order to do a one sample, all right, Z interval for P. Well, these are the conditions that we want to know. Well, because what we're looking for in a confidence interval is we want to be able to have our, all right, our statistic that we found, okay, and we're going to add and subtract our margin of error. Now, the margin of error is basically an area from our statistic that is going to go to figure out what we want to do, okay? And so now, in order to figure out this margin of error, given a P, okay, we're going to use a Z value because when you think about this, all right, this is kind of what we have right here. We're going to kind of say, okay, we have this value right here. We're going to say our P value is somewhere there, but we're going to assume that this P, that right here is our middle, is our mean, and we want to figure out, okay, what would be, all right, 95% or 90% or 99% of the area that probably the true P would be between, okay? What would the true P be between? And so when we have this, assuming that this is our thing, what is going to be our standard deviation that would possibly give us that 95% confidence, okay? 95% confidence, all right? Or probability, essentially, that we're looking for. So what we need to do is, well, first off, we have our point estimate, all right? So we find that. And then we have to know, can we use a normal distribution, our normal distribution? Well, in order to figure this out, there are several different things. So the conditions in order to use a one sample Z interval for P is that we have to know that we've taken a random sample. Okay, so it has to be a random sample. We also have to know if we can find our standard deviation, which is our standard error right here. So can we use this standard error or standard deviation, okay, formula? In order to do that, we have to make sure we have independence. Now, if you recall, independence can be found by using the 10% condition, 10% condition. So we're going to take our n value that we found in our random sample, and is that less than 10% of the population value? Okay, that will give us our independent and allow us to find our standard error formula, or we'll be able to use that. From there, we want to know, is this normal? Because if it's normal, then we can use a critical value that is a z-score, okay, a z-score right here. Okay, and in order to do this, we're going to figure out, okay, since we're giving a random sample to figure out what our point estimate is, our p hat, okay, we are going to do, okay, what n is times p hat. Since we don't know what the true population is, and that's what we're looking for, the true proportion is, we're going to use this assumption that this is the true proportion, all right, and we're going to say this right here, and we're going to have n value, and we're going to have 1 minus p hat right there, and we have that right there. Okay, so we're going to use the large count condition to figure out if it's normal. Therefore, we can use a z-score. Now, the critical values that we're looking for, all right, is because we're taking our point estimate plus our margin of error. Now, our margin of error is calculated by taking our standard error, all right, so that's our standard deviation, times the number of standard deviations that we have in our percent. Because if you recall, way back in the day when we did these normal curves, we realized that, okay, if we have our mean right here, okay, our 0, we can have this normal curve, and we know that, oh, this is a horrible normal curve, I apologize, all right, but 1 standard deviation away, all right, so if we take the mean plus 1 standard deviation away, all right, okay, from both sides, that's going to give us 68% approximately, 2 standard deviations away, approximately about 2 standard deviations away. So if we go, all right, right here, we have plus 2 standard deviations away, all right, from both sides, that right there, if you recall, is 95%, all right, and then you go 99.7%, 3 standard deviations away. Well, truthfully, 95 is not literally 2 standard deviations, it's approximation. The true critical value for a 95% confidence interval is 1.960. Okay, so we're actually finding the true z-score. We can use inverse normals to help us figure that out. Okay, so if you take an inverse normal on your calculator, take 1 minus that percentage that you want, divided by 2. All right, because whenever you inverse normal, this is taking, all right, for example, when you have a normal curve, if you have, like, for example, 90%, right here, okay, which is a 0.9. Well, we want to do the inverse normal of basically this little tiny section right there and find out, okay, what is that critical value going to be? Okay, what is that critical value going to be? And so what you realize is that, oh, this is divided into two sections, and so we're going to take that 1 minus whatever our percentage is and divide by 2, and that will give us our value that we want. That value always is going to be positive. All right, so that's the rationale. Hopefully you figured it out. But in any case, our critical values, if you just want to memorize these, all right, at 90% confidence, we have a 1.645. At 95% confidence, we have a 1.960. And 99% confident, we have a 2.576. All right, so once we figure out, okay, what our parameter is and our confidence interval we want, all right, we then plan by doing a one sample z interval for p. We check our conditions. We then go through the do part. Okay, the do part would be, okay, find your point estimate plus or minus our critical value. So whatever that standard or that critical value for our standard deviation would be for the z-score. All right, times then our standard error that we found for our sample. From that, in the last part is that we are going to conclude. And when we conclude, we just interpret what we find as our interval. All right. And so that is how we go about finding a confidence interval. All right. Need a point estimate. We find our margin of error by finding a critical value in our standard error, which is really just a standard deviation when we have a p. And we set that up and then conclude what we find. All right. The final thing is sometimes you need to solve for p or solve for n. Always round up, as I said before. And if you don't know what this p hat is, if it's unknown, you need to solve for n, just assume that it's 0.5. That's a conservative estimate of what p would be. All right, p would be about 50%. All right, well, that is how we can go through the four-step process, specifically, all right, for confidence intervals of one sample z for p, how you find the confidence interval right here, all right, how you check your conditions, and so on and so forth. We're going to go through some examples in just a little bit on applying this. All right, good luck and God bless.